Hello, statistics and pre-calculus, solving radical equations, the more challenging ones. You are probably watching this on Monday, but I am recording it on Friday. It's May 8th, and it's snowing outside. That is pretty cheesy, so I'm wearing the cheese fez. You may not ever see another cheese fez in your life, so be careful that you've seen it now. Solving radical equations, we're doing more challenging ones, but before that, let's remember the steps. First, you isolate the root on one side of the equation. Second, you raise both sides of an equation to a power to make sure that it lines up the same. 3, you simplify and solve that. And 4th, you're always sure to check your answers. You can create extraneous solutions. A couple people asked in the chat room about extraneous solutions for odd powers. It's really, I can't think of an occasion where you could create one where you're doing odd powers. Because the odd roots and the odd powers can be negative. It's mostly when you're doing even powers, including squares and square roots. So, one option, what happens when we have two radicals going on both sides? A radical on each side, you would originally isolate it, but you can't really. You could divide by 4, and then the x minus 2 square root would be isolated, but then the x plus 13 is going to have a divided by 4 on it. As of now, the x plus 13 is isolated. You do the best you can. So, we're going to just square both sides, but do it carefully. When you square both sides, you're going to get 4 squared times x minus 2 on this side. Make sure that you square the 4 also. So 4 squared times x minus 2 equals the x plus 13. A little algebra, and you work down to x equals 3, and you check your answer. Plug in 3, and I've got 4 times the square root of 1. Plug in 3, and I've got the square root of 16. 4 times 1 is indeed the square root of 16. Life is good. Practice with this one. See how it goes. Pause until you've got a good answer. And I hope that your good answer is negative 5/4 or negative 1.25, which you get when you cube each side. This is going to be 2 cubed, so there's going to be an 8 times the quantity 3x plus 2. On this side, you're going to get 4x minus 9. What about in this case? We do have an isolated square root, but here we have x plus 1. When you square both sides, you're going to have to be extra careful. The square of x plus 1 is not x squared plus 1. The square of x plus 1 is x squared plus 2x plus 1. You might remember that as square double square. You might FOIL it. You might do x plus 1 times x plus 1. And you have x squared and x and 1. But in any case, you really have to get x squared plus 2x plus 1 wherever you've got. You might have also done x plus 1 times x plus 1. That's another option. X squared plus x plus 1. However you do this, make sure you've got x squared plus 2x plus 1 on that side. It's a quadratic equation, and you solve quadratic equations by setting them equal to 0 and solving either by factoring, completing the square, quadratic formula, lots of choices. In this case, we have a nicely factorable one. X is negative 2 or x is 1. Check. When I check negative 2, I get the square root of negative 2 plus 3 equals negative 2 plus 1. So the square root of 1 is negative 1. That is a problem. The square root of negative 1 is not, or the square root of 1 is not negative 1. Again, this is where your squares have to be squares have to be positive. So this one is not working. That is an extraneous solution. On the other hand, if you plug in 1, you get 1 plus 3. Square root of 1 plus 3 is 1 plus 1, so square root of 4 is 2, so that one does work. You have one solution in this case. You might have, when you're doing one of these, if you get 2 solutions, you might have 2 good solutions. You might have only 1 good solution. You might have no good solutions. It's possible that they're both extraneous, so that's why it's important that you gotta check. All right, go ahead and practice with this one. See how it goes. Hit pause. And come back, and you're right. You've got the answers x equals 5 and x equals negative 4, but wait, did you check them? If you plug in 5 I have the square root of 45 minus 45. That's the square root of 0 equals 0. Well, that's pretty basic, but it works. So that's good. If I plug in negative 4, I've got 45 minus 9x. So minus 9 times minus 4 is plus 36. I've got the square root of 81. And on this side, I've got negative 9. The square root of 81 is not negative 9. It's positive 9. An extraneous solution. So the solution here is x equals 5 only. Yet another. What happens if the exponents, instead of being a perfect square root or a perfect cube root or a 1/2 or a 1/3 power, what if we've got this 2/3 power thing going on here? So what you do, if you have an expression to the a over b power, take both sides to the b over a power. So I've got the 2/3 power. I'll take the 3/2 power. And you notice on the left side, I'm going to get x to the 6/6. That's just plain 1. So x to the first power. On the right-hand side, 16 to the 2/3, that's the square root of 16, which is 4. To the third power, 4 to the third power, 64. So again, this side, you got x to the 6/6, just x. This side, 16 to the 3/2, which is square root third power. Go ahead and practice these. There we go. And we're back with your solutions. In this case, you take both sides to the 2/3 power. 125 to the 2/3 is 25. So we've got 2x minus 3 is 25. X is 14. On this side, you do have to isolate first before you do it. So you subtract 2 from both sides, divide both sides by 3, and now take the 3/4 power. 16 to the 3/4 power is 8. X plus 1 is 8, and with a little magic algebra, a little like heavy-duty lifting, you'll get x is 7. There we go. Last question of the last video of Chapter 11, of Module 11. An application. Can we handle an application? First, this is off page 612. A lot of the more from the book, but there you go. For a spinning amusement park ride, the velocity in v meters per second of a car moving around a curve with radius r meters with acceleration a meters per second squared is given by the velocity is the square root of the acceleration times the radius. So if a ride has a maximum acceleration of 30 meters per second squared, so that's basically twice gravity, so that's good acceleration. And the cars on the ride, no, it's basically 1 times gravity. And the cars have a maximum velocity of 12 meters per second, which is pretty fast. What's the smallest radius curve that any curve on the ride can have? Well, we're given acceleration of 30 meters per second. So put that in for acceleration. We're given velocity of 12 meters per second. Put that in for velocity. This is not an especially challenging problem as you do it this way. Go ahead and square both sides. 144 is 30r, and you get r is 4.8, the minimum, so minimum radius of 48 meters. 4.8 meters. Just for fun, you're assuming that this is 4.8 meters because you're like a radius has to be a distance, but let's talk about what happens with the units as you do this. The 12 is in meters per second, that's your velocity. Maximum velocity is 12 meters per second. The acceleration is in meters per second squared. Now when you square both sides of this equation, you've got 144 meters squared over seconds squared on the left. On the right, 30 meters per second squared times the radius. Now you're going to divide. We're going to divide by all of these, and let me pick a different color. We're going to divide, and second squared is going to cancel second squared, and meters squared is going to cancel 1 meter, is going to cancel meters. Hello, you're not writing very well. Whatever. So you know that, oh no, now it's there. Good. We got a meter squared. In any case, what's going to happen is you're going to have, what? Sorry, the video's going crazy in the last seconds, but it's too late to record. In any case, what you're going to have is r is going to work out to meters. R is going to work out to meters on the end, the last slide. There we go. Sorry for the delay at the end, but you've got the meters. This meter will cancel one of those meters, and so 4.8 meters. Units work out great. Congratulations. This was a challenging topic. Some good practice on the homework, on the problem sets. You can have a lovely